So in this question, we want to solve an inequality, show the solution set on a number line, and also by using interval notation. So let me pause a second here. So to solve the inequality below, we also want to show the solution set on a number line by using interval notation. As I said, this is similar to solving equations. So if I want to look at this as y minus 1 is equal to 1, that's how we can add 1 to both sides, if you will, to get rid of that constant. So y would have to equal 2. So now step 2 becomes a critical point that I can actually place on the number line. Now the catch is, what we want is if you put the 2 in, 2 minus 1 is going to equal 1. But what we want is something that's actually greater than 1. So to be greater than 1, the question is, should we be picking values greater than 2, or should we be picking values less than 2? Well, it would make sense that if I want to make this side bigger, if 2 makes it equal, then I need to pick values bigger than 2. So notice how we have to be greater than 1. Well, 2 would make it equal to 1, so I do not want to include the 2. But what I want to do is I want to shade to the right of 2. So that's kind of the thinking in this is I want to find what makes it equal, but then I have to figure out what makes it greater than. So what we figure out though is in y minus 1 is greater than 1. If I want to, I can just treat this just like an equality and just get y by itself by adding 1 to both sides. If you add 1 to both sides, so if I add a 1 to both sides, notice that this does give me y is greater than 2. So notice that this kind of helps me pick up on, I didn't put 2 down there, did I? So notice how this helps me identify a critical point. And then the greater than symbol helps me understand which way to shade. So notice how it's pointing to the right. This is kind of telling me to shade to the right because greater than means to the right of that critical point. And since it's greater than, notice how greater than means we do not include the endpoint. So we solved the inequality, so the inequality is going to be greater than 2. We graphed it on a number line. Now the question is, what does it look like in interval notation? So in interval notation, notice how we do have a left boundary, which is 2, but notice how we do not include it. So since we're not including the left boundary, we're using a parenthesis, and we place 2 down as the boundary. But notice how this keeps going to the right. So notice how there's not a right boundary. So if there isn't a right boundary, we actually use infinity. And remember, when we use these infinities and negative infinities, they always are accompanied with a parenthesis. So from 2 to infinity would be our interval notation for that. So when I solve it, y is greater than 2 would be our solution set as an inequality. So this means all numbers greater than 2. This also means all numbers greater than 2. And this also means, all numbers greater than 2, because this parenthesis means do not include the 2. So 2 to infinity, but not including the 2, since that's parenthesis there. So there's 3 ways to represent this solution as an inequality. I can draw it on the number line and also using interval notation. So notice how this is different than an equation. An equation, there would only been one solution too. But with inequalities, there are so many solutions, we can't name them all. So all we can really do is describe the solution. It's more of a description than anything else.